Hi everybody, this is Rick here and welcome to Digital Fortress. Today's video is going to be about UTXO, which means unspent transaction output. Now the purpose of this video is for beginners or people who want to learn more about unspent transaction output and how it works. At the beginning of the video I'm going to briefly explain it, then later on in the video there'll be a more in-depth explanation. And the purpose of this video is because in Daedalus wallet I want this to be very specific to how UTXO works in the Daedalus wallet and what you're looking at, because when I first started using it I was very intimidated by how the transactions look. So let's take a look at that first of all here. On the left hand side here I have a wallet called All the Money in the World, just an example, and I sent a transaction. And the reason for this video is because what will happen inevitably is as you use Daedalus or Yoroi, same thing applies to Yoroi, you're going to have transactions sent to and from. The balance of the wallet is shown here on the top left side, and also at the very top center of the wallet you have a balance, and you have these transactions that say $0.08. And what the purpose of this video is you're going to end up clicking on these transactions and saying, oh, what is all this weird gobbledygook under here? There's a bunch of crazy numbers and some transaction IDs. You're going to click on them. Like, here's a to address, and I said, oh, I sent my ADA, I sent 4 ADA to this address. What does that mean? So I click on it on the left here, and over on the right in the web browser it popped the Cardano block explorer. That's the default. And so what do I see? I see an address that I sent from, and then it went to somewhere, a bunch of other stuff, and it was 4 ADA, and then up here it says 7 ADA, and this says 3.8 ADA, and it's like, what is all this other stuff? What is this number doing here? What is this stuff doing here? But the balance is right. And you go up here and you look and go, well, the balance is right, but what are all these other things that are going on down here? And that's what I'm going to explain. So you got these block explorers. The default is Cardano Block Explorer, currently undergoing revision. I saw it's like an example of the new one. It's going to be really nice. But you also have Clio.1 and understand..Net. I'll show you what I mean by that. So if I take the sent transaction I have over here, some of these block explorers are easy to read. I'm going to copy that transaction, or I mean the to address. Here's a transaction ID. You can click on that too. So I'm going to copy the to address. I'll go over to Clio.1. Let me make that bigger. Okay, then I go in here to where it says address checker, and I'm going to paste this address in, and I'm going to see the correct balance. There's a balance, 4 ADA, which matches the wallet. It's I sent it to this wallet here, and the balance is 4, and here's the ADA received, 4 ADA, and here's the other side of that transaction. Okay, but Clio.1 is really easy to read. I can see the balance is 4 ADA. I don't have all the confusion that I see here, but this is very important. I just call confusion, but that's not to downplay it. All this stuff makes sense to a software engineer, but to us normal human beings, maybe not so much. But for blockchain, it is very important to have that type of data. That's the data that keeps the blockchain intact. And that's what makes it called UTXO, unspent transaction output. There's also another really cool block explorer I'm going to talk about later in the video a little bit here, and that is adascan.net. Adascan does the same thing. You can put the address up here. I can paste it. Now, Adascan goes into much greater detail, but look, the balance is 4 ADA. Balance is 4 ADA. Okay? But this is easier to read. Now, in Adascan, it goes into much greater detail. Clio goes in greater detail too, but Adascan kind of gives you some more data up front. But this isn't a review of the different block explorers. However, there are different block explorers to help you understand these. If you need to start simple, Clio.1. If you want to go all the way under the hood, adascan.net, and the default Cardano Block Explorer, which is getting a facelift here shortly. And that helps explain these transactions. So the next section of this video, I'm going to explain a basic money transaction using a real-world example, spending money on a taco. I like that example. And then later on in the video, I'm going to go into greater and greater detail, and I might screw it up, but just kind of bear with me, of transacting from wallet to wallet to wallet, and then looking at them And you don't need to watch way further on in the video. I'm going to way overkill this so that you can go to the level of detail you want to see practice transactions and get the hang of it without having to lose those transaction fees. You can see some examples, then you can practice this at home also with very small amounts, just so you can get the feel for it and say, okay, now I understand what this UTXO thing is. So let's take a look at a real world example first. So in this basic example, I'm going to show you two forms of transactions: the standard accounting that you already know and use all the time, and the UTXO version using physical money, so that it makes a little more sense later when I start showing you how it takes place on a blockchain. So in this first example, here's my wallet, here's my money in my wallet, my change, it's in my pocket, and over there is the taco store. So I go to the taco store and I want to buy a taco. In order to do that, I say how much is the taco, and the person tells me it's $1. So I say, all right, here's $1 for my taco. I lay that out on the table. They give me my taco. And they take their dollar and put it in a register, okay? And so now the transaction is complete. Let's reset the scenario and look at a UTXO transaction. Okay, we're reset. So in a UTXO transaction, you put all of your money on the table, an exchange occurs, and the rest of it comes back as change. Here's how that would look with real physical money. I go to the taco store, I want to buy a taco, and it's $1. So the way it works is all my money goes out on the table, $1 comes out and goes in the register for where I'm buying the taco, then the rest of my money comes back as change, and I get my taco. So in this example, why would you say, well, what is the purpose of UTXO transactions? It prevents people from counterfeiting money, and it prevents money from being double spent. Now, double spent may sound unfamiliar to you if you're new at this, but double spent is something you can do with checks, for example. If you're used to using a checkbook, let's say you only have $100 in your bank account, and you write a check for $100 and you give it to one store, and then you immediately go to another store and you write a check for $100 and you give it to another store, and you take your products and you go home, and now you have $200 worth of products and you only have $100 in your bank account. You just double spent that money. One of them is going to bounce. One of those transactions is going to get rejected. With blockchain technology, you can't do that because you put all of the money on the table, they get their piece, you take all of it back as change, and that's how it appears on the Block Explorer, if that makes a little bit more sense. So let's take a look at how these transactions look on the Block Explorer. And I'm going to have my taco. So here I'll touch on briefly as to how blockchains work and why they work that way. In blockchain, every bit of money you have, it came from somewhere, and then when you spend it, it's going somewhere else. Now with standard money, you have, let's take these quarters for example. Okay, I don't know where these quarters came from. This quarter may be change from the last time I went to the taco store. This could be change from the hardware store. This quarter, I don't know where it came from. That could have been change from the grocery store. This one might have been used in a liquor store robbery or heist. We don't know. It came from somewhere. All we know is where it originated. For example, this quarter has a P on it, so it was minted in Philadelphia. It traveled around the United States or around the world, and it ended up with me. I just know it came from Philadelphia, and now it's in my pocket. Now with blockchain, it keeps track of that kind of information. This quarter has a D on it, so it was minted at the Denver Mint. Then it circulated throughout the population, and it ended up back in my pocket. Now with blockchain, it keeps track of where that money came from and how it transacted. You don't know who had it, but it has an address. It has an origin called the Genesis block, and it has a current state or current existence, which is in your wallet or in somebody's wallet somewhere. So the blockchain keeps track of how that money is transacted. That means you can't just create money out of nothing unless it's minted by the blockchain or the software that governs the rules of the blockchain. You can't counterfeit it, you can't double spend it, and what that does is it prevents whoever's in charge of the money supply. Currently, with this physical money, they can print an unlimited number of bills. They can mint an unlimited number of coins, only limited by the amount of metal that they can dig up. And so with blockchain, it has a much more restricted source of the money as long as the blockchain is complying with the rules set out with the blockchain. Now, you would think that the money is traceable back to a person, but it's not. It's only traceable to an address. Like once I spend this dollar and it goes off, I don't know where it ends up. It goes into a big pile of somebody else's money, then it goes into a big pile of somebody else's money somewhere else as it continues to move. Just like blockchain, it's just that blockchain goes from address to address to address. We don't know who owns that address. We just know that the money came from some address. It went to another address, but it can always be traced back to the Genesis block, or that it was minted by one of the slot leaders winning. But that's not part of this discussion. Now let's take a look at the environment that I'm going to use to give you the example of how UTXO works in Daedalus. I'm going to go to my desktop here. Now I'm working on a Mac computer, and a lot of you are familiar with Windows. On this Mac computer, it's a pretty powerful computer. It's a Mac Pro 2013 model, and I'm running virtual machines. So a lot of people are familiar with Windows. Here's what Windows looks like, and I'm going to be using Daedalus as an example. But I don't need to use Windows for Daedalus as an example. I'm just showing you this because you're familiar with it. So I'm going to close Daedalus that's running here on my Windows virtual machine. Once Daedalus stops, I'm going to shut down Windows. That's a virtual machine. I'm using a virtual machine environment so I can show multiple wallets at the same time. Here's a virtual machine software called VirtualBox, and it has multiple virtual machines on it. What this does, it allows me to run multiple operating systems as if they are their own computer. Okay, this doesn't have anything to do with UTXO, but it's just so you know what you're looking at. So I'm going to put this away because we don't need it for the purpose of this video. What I have here is a Daedalus wallet called All the Money in the World running on Mac OS X, which not everyone's familiar with, so I just wanted to let you know. Same thing as Windows. I mean, you kind of get that, but this is a beginner's video. And here's one wallet called All the Money in the World, and I'm going to start with 1,000 ADA. Although there's about 30 billion some ADA, I'm going to just say all the money in the world is 1,000 ADA, and I have a fresh, clean, empty wallet called the exchange or the bank that has no ADA in it. I also have some other computers running. Here I have Ubuntu Linux. It's a very lightweight installation running what I'm calling Wallet 1. I have another copy of Ubuntu Linux running what I call Wallet 2. And I have a web browser running that's running a block explorer, which runs out there on the internet, and it shows the inputs and outputs of the wallet. I'm going to go back over to Daedalus, to a wallet called All the Money in the World that starts off with 1,000 ADA. And I'm going to send 100 of this ADA from All the Money in the World to the exchange wallet. So I go to the exchange, I select receive, I copy the address, and I take from All the Money in the World, and I hit send, and I send that money. 100 ADA. It calculates the fee for the transaction, the total amount of ADA, and I hit next and enter the password. So I sent 100 ADA from All the Money in the World, 1,000 to the exchange, 100 ADA. So from 1,000, 100 comes over here. So let's take a look at where that money went. I'm going to go into the ADA received, and you'll see where it came from. This is from All the Money in the World, and you'll see there's a bunch of different addresses in there. And what I'm trying to do is establish my baseline 100 ADA that I'm going to start with from the exchange. And where did it go? I only sent 100, and it went to 2 addresses. The first address, I click on it here, and when I clicked on it, it showed up over here. So this is the address of my wallet, VZH, I'm just going to use the last several letters here, VZH8WEEXJ, and that's going to be the address of my wallet. You see how those letters match, letters and numbers match here. I'm just going to call them numbers because that's what they are. The numbers match right here. Okay, and there is another address in here. Now when I click on the other address, it's going to show up over here in the Block Explorer, and it'll show the balance of that address. So I click on it, the Block Explorer updates and shows 899. So the other 2 address is the wallet where it came from, All the Money in the World. You see how that works? One address is my wallet, and the other address is the wallet it came from. That is the unspent transaction output, or basically the change that I described earlier in the taco video. And I'm going to see what it looks like you got other ones called ADA Scan. These are all Block Explorers, ADA Tracker, and Clio.1. So I'm going to expand the screen. Then I'm going to paste that wallet address in. Hit enter, and it finds the transaction, and it shows 100 ADA is the balance. Now, these different websites, they all do similar functions, but they display it in different ways. Some of them are easier to read than others, and I find this one, adascan.net, particularly easy to read. So just point out, there's another one called ADA Tracker, and there's one called Clio.1. It has an address checker. And you can paste the address in there, and it shows you the balance of the address over here. That's how you can check your balances. Okay, I'm going to put this web page back up in the corner. I'm going to come back over here to the exchange or the bank. Now that I have my baseline, I have an exchange or a bank, and then the other 2 wallets, Wallet 1 and Wallet 2. I need to exchange addresses so that I can send from wallet to wallet. Addresses, it's okay to send them out. I did not, because you can only receive money on addresses, which you have to be careful with, are private keys. You don't want private keys to get loose. But the addresses, like the one you see here on the top right, those are publicly available. It's just that no one knows who else has which address. That's why you remain anonymous, even though you have addresses out there. That's also why I'm not using a real exchange like Bittrex or Binance, because I don't want my real addresses out there. So I created the simulated exchange over here on the left. So to send funds to another wallet, I have to have the addresses. Let me show you briefly so you understand where I get them from. I'm going to open this web browser, and in this web browser I have my iCloud, and I have the addresses in here. So in my iCloud I put the exchange address, the address for Wallet 1 and Wallet 2, just so we can look at where that money's going to and from. And addresses are okay to put in the iCloud because, I mean, for me anyway, I'm okay with putting them there, because you can send stuff to addresses. The worst thing happen is someone can send me money if they've got in there. But we want to be careful. Do not put things like private keys and passwords on the iCloud. Okay, so that's on my Wallet 1. Also over here on Wallet 2, I have my iCloud pulled up, and I have the wallet addresses. So I can send and receive from the different wallets because they are technically on different computers, and they could be anywhere in the world, and it will work exactly the same way. So that's just to give you an idea of what we're looking at here. Next, I'm going to send 50 ADA from the exchange to wallet 1. Wallet 1's address is shown here, so I need this address to send money to it. I'm going to copy the address for wallet 1. Go to my exchange. Send 50 ADA. And put in a password. There goes the transaction. It's going from wallet 1 to wallet 2. The outgoing pending confirmation, I sent 50 and it appended the transaction fee. That money will show up down here in wallet 1. There's 50 ADA and it shows the ADA received. Now this is a brand new wallet, so it has, it's nice and clean. It only has one address in the received section here and one down here. But as you use a wallet, you'll notice those addresses accumulate. So here's my ADA received. The from address, it only came from one address because I used a nice clean start with this exchange wallet up here. And it went to 2 addresses. Here's one of the 2 addresses. Sorry for the small text. It's kind of hard to fit this on a screen. I'll try to get really good resolution. But let's see. So here's one of the addresses. And here's the other address. This is the wallet address because I just looked at it. So it came from this address and went to these 2. Let's take a look at this on the Block Explorer. So I click on it. It opens the Block Explorer. And here it shows the final balance of 49.827919, which matches the exchange or bank where it came from. This is the unspent transaction output. This is the change. When the 50 was sent, basically this wallet up here put 100 ADA on the table. 50 ADA went to the wallet it was going to, and the remaining 49.827 ADA went back to the wallet it came from because it's minus the transaction fee. Right now the transaction fees they kind of vaporize. They go into some wallet out there in the world. But if I were to take it from a real exchange, there might be 3 addresses listed here. One would be the sending address. One would be the receiving address, and the third one would be the exchange address where they put all of their transaction fees. So you might see that. I just can't demonstrate it here just yet. So we looked at the top address, which was the sending wallet getting its change. Now look at the bottom address, and this is the receiving wallet. So you see the 50 ADA is here. So it takes a little practice to kind of get the hang of this. At least for me it does. To make sure I understand it thoroughly. And that's what we're trying to do. So the money came from here. And it went to this wallet address. And the change went back to this address. So what is this address? I don't know what that is. It's WYWDMNV9Y. So I'm going to come back up here and take a look at this wallet. And I see that there's a new address in here. Remember I started with just one, and it was this H8WEX. Now there's another address, and it matches this address. This took me a while to figure out. For me, this is exploratory surgery. See this address down here, DMNV9Y? It's from the originating wallet. That's where the change went back. You don't know where that change went, but now, I mean, you wouldn't know, but now you know. You see where it goes. And that's why these wallets, every time you use them, you'll see these generated addresses start stacking up more and more and more. If you send out, you're going to get your change back in a different address. It's still the same wallet. It's still in the same place. So let me go back to the summary. take a look here. Now I have a wallet that has where it came from, the original address, my wallet address, and the change wallet address going back to the originator. Okay, and I can verify my wallet address by looking here on receive, and I see it's the PQT4YE. Then I go back to the summary, and it's the PQT4YE. There's another thing to look, you can look at in here, down here, it's called the transaction ID. The transaction ID can also be looked up. I'm going to click on it. That will open the Cardano Block Explorer, and it will show you the transaction information that I just showed you on Daedalus. And again, this is a bit exploratory for me as well. Now next I'm going to do is get another 50 ADA. Let's say someone gives me 50 ADA and I am wallet 1. Then I'll have a total of 100 ADA. So let's go out into the world and have someone give us 50 ADA. Let me first get my wallet address for wallet 1. Then I'm going to go out into the world and have some benevolent person send me 50 ADA. There's my 50 ADA sent out, and we'll observe it come in. It's usually pretty quick. We'll see. Okay, there's my 50 ADA received, transaction pending. It's waiting for confirmations. Now I have 100 ADA nice and round in this wallet. I got 50 from all the money in the world, and I got 50 from the exchange or the bank. And the sender, in this case, paid the transaction fee. In the future, you'll probably see where you can make it so that the receiver can pay the transaction fee as well. So now my wallet 1 has 100 ADA in it, nice and even. I had one address in here, and I still do. I've got one address. Next, I'm going to send 25 ADA from wallet 1 to wallet 2. And that way you can see how this UTXO continues to work. It's to help continue the example. So I'm going to copy the address for wallet 2. I'm going to send to wallet 2. Then I hit next. Now we're sending 25 ADA to wallet number 2. And this is where we're going to interact for a bit here between wallet 1 and wallet 2. Now remember, wallet 1 just had 100 ADA in it. And it only had one address. And now it has 2. So it had 100 ADA and one address. The 25 ADA was sent to wallet number 2, which had one address, and it still does. Now let's see what happened over here on wallet number 1. I have ADA sent 25, and it came from address, and shows 2 of the same addresses here, and to address these 2 addresses here. And it was very similar to the first money we sent from the exchange to wallet 1. It generated 2 addresses. One of them went to wallet 2 over here, and the receive address is BESG6, and the other address is NED3K9ALWEN. So here's your BESG6 address. If I click on it, it'll open a block explorer to wallet number 2, and there's the 25 ADA. Let me put this away for a moment. I'm going to click on the other address. This will be the change coming back to wallet number 1, and here's the 74.819 ADA showing in this address. I'll put that away again. And here's the transaction ID, and I click on that. The block explorer shows the transaction ID with the address input to wallet number 2 and the output back to wallet number 1, which is the 74. So you can see I'm using nice round simple numbers that fit in your head, so you can see how this works, and it makes sense, because when you start using the strange numbers you get off of the exchanges, you might get 103.279 ADA, and when it comes off an exchange wallet, it has a whole bunch of addresses over here, and it just doesn't make any sense. So doing this, bit by bit helps me understand it, because I'm not a pro in this, but fortunately there's a bunch of software engineers out there who really get how this works. So there you go. Now I thought these two addresses over here, let me go back to Daedalus. I'm going to go back over to Daedalus, and the from address, I have two that are the same. I thought these were supposed to be different. It's possibly that they're both the same because I got it from the same source. Oh wait, I did get it from the PQT is where that money came from, and from there, let's see where that address is. It's this one. Okay, so yeah, all the money came out of this address. That's right. That's right. Okay. Sorry, I had to get a look at it from there. See how it can be confusing. I thought it was going to get one of the addresses from up here on the exchange or the bank, and the other one from the world to say where it came from, but it actually originated from this address. So we're going to be sending some more money in a bit and see how that works. And then over here we have ADA received. It came from the same addresses that were over here. Sorry, let me show that. And 2, and it lists the same 2 different addresses. One of them is the address for this wallet, and the other is the address where it came from. And the balance is 25 ADA. Alright, next I'm going to go back out into the world and send enough ADA to round this back up to 100 nice and even. And then make another transaction and send it over here and see how that goes, just for practice purposes. So I'm going to go out into the world. I'm going to copy the address for wallet 1 again. And from all the money in the world, I'm going to send to 1. I'm going to round up to 100 by subtracting the balance of wallet 1, which is 74.819789. This is the amount I'm going to send to wallet 1 to round it back up to 100. 1, 1. Off it goes. And now when that money comes in, it will round wallet 1 back up to 100, and the exchange fee or the transaction fee came out of the origin. In this case, it came from all the money in the world, just somewhere out there in the world. And I'll go back up to the exchange up here. So now I'm back up to 100 ADA. And now I have money from different sources. I have some money that came from all the money in the world, and I've got some money that came from the exchange or the bank. And I'm going to send another transaction over to wallet number 2. Now wallet number 2 right now has only one address in it. So I got to get the address for wallet number 2. I'm going to send 25 ADA to wallet number 2. That'll round it up to 50. Send that ADA off, and it's coming over to wallet number 2. Now that 25 ADA got to wallet number 2 and rounded it up to 50. Let's see how many receive addresses we have. We still have 1. And how many addresses are over here? We are up to 2 addresses, and now we have 3 addresses. So why is that? Well, I sent another transaction over to wallet number 2, then I got my change back. So I sent 25 ADA, and what that does is, this wallet had 100, so it puts 100 on the table, going to wallet 2. Wallet 2 gets its 50 ADA, and wallet 1 gets the change back, which is 50 ADA minus the transaction fee. Okay, so let's take a look at that output. It came from here, which is this wallet's address. I can see it here in the receive section. It's my original address, PQT4YE. It came from there. It went to wallet number 2, BESG6. And here is wallet 2, BESG6. And the remainder went to an address called KUT7KRDS, blah, blah, blah. I'll just stick with the end. And let's see where that is. And here it is, KUT7TKRDS. So it came back to my wallet. That was my change coming back. And let's take a look at that transaction. Here's the money coming back, right? So I click on it, it opens the Block Explorer. And oh, look at this. I got that funny balance. I got that. So here's the sent 25. And then this little bit that went off here. I don't even know where that went. I got to figure out where it went. But it's still in my wallet. I didn't lose it. It just looks funny, you know? So you got to look at it and get the hang of doing this. Here's my current wallet that I'm looking at. I can click on it. It opens up the Block Explorer, and it says, yep, there's 50 ADA in that transaction and the final balance that's at that address. But you look at it and go, wait a second, my wallet has 75 in it. Yeah, that gets confusing. 74. So the next part I'm going to show you is another thing that used to confuse me, and to be honest, it still does sometimes. And that is what happens when you receive money to different addresses. So if you remember, in wallet 1, the original address was PQT4YE, and when I send money, it comes from that address. But what happens if I receive money to a different address? Well, the wallet just keeps track of it for you, because all these addresses are understood by the wallet to be all part of the same wallet. They're different addresses, but they still live on some crazy thing called elliptic curve cryptography or something like that. And yeah, so all these addresses are basically belonging to the same wallet no matter what. So let's see what happens if we start using these other addresses. So let's again review our last transaction. We sent 25 ADA minus the transaction fee from wallet 1 to wallet 2. Wallet 2 had 25 in it, 25 and 25, and now it has 50. I mean, this is the easier part if you just look at the numbers over here. Now it has 50 ADA in it. And I've been using the same address for each of the wallets. So let's see what happens if I use a different address. I'm going to go to receive. I'm going to copy this LWEN wallet because it's easy to remember. I'm going to copy that and stick it in my iCloud. I'm going to call it wallet 1 second address. That way I can get to it on my computer and I can send it from this Daedalus. Okay, so now I open up my reminders and it will show up in here because that's what the iCloud does. That's what I just pasted in there, so I copy it. Okay, so now I'm going to do that send. Let me put my display back so it looks right. Now here's where I'm going to send from here. And remember, I kept using the same address, ADA sent, to this PQT4YE address, okay, which was wallet 1. Now I'm going to round it back up to 100, so I'm going to send it to a different address in the same wallet down here. So let me come back over to summary for a moment. Oops, I'm already there. I need to calculate how much I'm going to send to round wallet 1 back up to 100 again. Okay, so I need to send 25.172081 from the exchange to wallet 1. So it's sending the 25.17081 plus the fees, and I hit next, password, and I hit send, and down here in my wallet 1 we'll go back to 100 ADA. Now before that completes, I'm gonna show you, I'm gonna explain what I'm trying to do here. Now it's back up to 100 ADA, so I'll go back to the summary here. I need my address for wallet 2 because I'm going to send to wallet 2. And what I say, I was going to send 80 ADA to wallet number 2. And I hit send. There's the outgoing transaction, and we should see the 80 show up over here shortly. All right, there is our 80 ADA showing up in wallet number 2. Now we see wallet number 2 still only has one address. It's been receiving only. Now I'll go back to the summary and say, where did I receive this ADA? This is what the part I was trying to show you, the unspent transaction output. You see how I now have multiple from addresses over here? It came from many different places. It went to here. This is the address for wallet 2, the BESG6. And then again, oh, here's another address. I don't know where that came from. But the key is, look how the 80 ADA came from 2 different addresses. So I'm going to go back over here to wallet 1 and look at the sent. Same thing, right? Then I'm going to go to the addresses where they're in the receive, and I see that I now have a new address. I've got that K9ALWEN, and I have another address, the 7TKRDS. That's also another address where it came from. So I come back over here where the ADA came from multiple addresses. Let me look at the transaction ID on the blockchain. It's probably look the same as it looks in Daedalus. Yeah, it does. Here's the multiple addresses. These two are the same. This one's different. Where to go? It went over to one address, and the change went back to the originating address. the change coming back to wallet 1 was 19.811 ADA. Let's see if I can find that over here. Let's see, 2. Okay, it should be this one. Okay, so this should be the 19.81 ADA going back, and it was. There you go. So it's the output. The output, I think, to me, is easier to understand than the inputs. The inputs will come from multiple places. Oh, we got that little red screen there. It'll come back. So we're going to start over shortly here. So I'm going to send all of the money from wallet 1 and wallet 2 back to random addresses over here in the exchanger bank. And we'll see what the effect is. But just kind of remember that blockchain, it always knows where money came from. And that's why we're doing this, so we can see how it gets there. So I'm going to send all the money in wallet 2 over to wallet 1 at this address, 4ZWQKM, 4ZWQKM. That's one of the addresses that was never used before. And I'm going to send the whole amount, 130. I send it back to the bank. Oh, it says not enough fees. Try sending a smaller amount. So I'm going to do my little trick where I'm going to do 129. And then last is 9 because it ends with a 1. Otherwise, I could just use the calculator and subtract that. So 130 minus this number is this number. I just went the long way about it. Okay, hit next. I'm going to go over here to wallet 1 and send the rest back to the bank. I'm going to send it to this address. I'm sending it to a different address. To make a point, it's 19.81659 minus some fee. So I'm going to take the balance minus the transaction fee. That's how much I'm going to send. So I send the remaining balances back to the bank up here. And it includes some of the money that came from out in the world. All the money in the world location. And there it is. So now the wallet balances are 0. Now the money from wallet 1 and wallet 2 have been sent back to the bank, plus the additional money that we extracted from the rest of the world. And if you recall, when we started our first transaction, we sent, the bank had 0, then we put in 100, and the world had 1,000. The total in the world, all the money in the world was 1,000. We sent 100 to the bank, and there was only one transaction, and there was only one address. So there was one address in the bank, and now there's 3. There was only one address in wallet 1, and now there's 4. There was only one address in wallet 2, and there's still only one address in wallet 2. So at this point, all the money in the exchanger bank, it had circulated through the world. It went out through the different wallets and it came back into the bank. Now I'm going to send to wallet 1 again. 50, just like we did before. And there was only one address in the exchange of the bank, and there was only one address in the wallet. Wallet 1. So I go to wallet 1. I'm looking for the 50 ADA to show up that I just sent from the bank. And there's my 50 ADA. Now recall, there was only one address the first time we did it, and it only came from one address. The first time we sent 50 ADA, it only came from one address. Let's take a look now. ADA received from, it has 2 addresses marked here, then to address the one used here, and the return money is the same. That was just sending 50 ADA. I wonder what would happen if I sent all of the ADA. Let's take a look at that. let's take a look at the from address. So let's send all the money from the bank to wallet 1. And I'm pretty sure we're going to see more than one address here, because if you recall, as I recall, once I exceed a certain amount, it's going to pull the ADA from different addresses from up here in the bank. So let's see if that's what it does. Let's send a remainder. So now I sent 123, which is all the money in the bank, except for this little bit here. The cool thing about ADA, it doesn't have something called dust. But I sent all the money in the bank, and I have 1, 2, 3, 4, 5 addresses. I've got 5 addresses in the bank, or the exchange. Then I come over here, here's my 123, and I see the from address, and the from address came from 2 different ones this time. There's actually 2 unique addresses. I say how much came from each address. So I click on one of them, and it opens a block explorer, and it says the output was 123 and 0.05, and this 0.05 would be the change going back to the other address. So I received the 123. If I want to look at the specific transaction, I click on the transaction ID, and here it shows the same or similar format: how much was sent, how much was returned to sender, and the total of that transaction. You can see the addresses are starting to stack up here in the list the more you use the wallet. Of course, I can hit generate new address if I just want to create one to receive from, and I don't want anyone to know what that is. I don't want to know the balance. Then I can just type in a password and generate a new address right here. So here I hit generate new address. It pops up here in the top. You see this little marker that says show used. I can hide the used addresses. So now I'm going to take the address I just generated. I can check it on the block explorer. It's a fresh address, so it'll have a 0 balance. So if I want to return something to my wallet, I can generate a new address and have a 0 balance in there. Now I'm going to send all the money back out into the world and reset the bank to 100 ADA. So now I'm back to where I started. Okay, all the wallets, wallet 1 has 0, wallet 2 has 0, and the bank has 0 ADA. It's all been sent out into the world, into all the money in the world. Now remember, all the money in the world started off with 1,000 ADA. Where did the other 2.5 ADA go? Well, it was consumed in the transaction fees, and that will go into the treasury. That's so that would have been treasury money for the transactions that I put in there, or the transaction fees for the exchanges. It's like the cost of doing business. All right, so what did I lose there? It was 1,000 is 0.501436. Okay, so 2.5 ADA was consumed in transaction fees from all the money in the world. Now that money would go somewhere. It would go to the exchange or the treasurer, wherever that transaction fee was assigned to go. So it just gives you an idea of what those transaction fees are. So I'm going to go back to the first step we did and send, instead of 1,000 ADA, I'm going to send 990 ADA to the bank. And instead of it going from one address, we should see it going from multiple addresses, even though it's coming from the same wallet called All the Money in the World. So I'm going to send And this is just to re-emphasize, if you're still watching the video at this point, you are one tough son of a gun, because I know it's a long video. So I sent 990 ADA to the exchange. That 990 ADA is now coming from money that's been circulated throughout the world here. It went out through all these different wallets, went back to the source. Now it's been received. And let's look at the from addresses now. Let me make this nice and big. Now we see this 990 ADA came from 3 different addresses. Even though it came from the same wallet, it came from 3 different addresses to this wallet, and again the remainder back to the original. So let's see, this is how blockchain works. It's all traceable. So let's make 2 nice big screens here. We got the Block Explorer on the right and Daedalus on the left. And now this money's been out circulating. So these 3 addresses should add up to 997. So I'm going to click on it and let it open. Here's the 990 received. Now we're going to check the addresses. And what I'm going to use, instead of the Cardano Block Explorer, I'm going to use ADA scan. It's pretty easy to read. So now that I sent the 990 from all the money in the world over here to the bank again, we got 990 here. I'm going to go to ADA received and check the transaction ID. I'm going to copy that. I'm going to go over here to adascan.net. I'm going to paste the transaction in there. There's the result. Gives you the balances. Pretty cool. Well, I hope you found this video helpful. It was a pretty long video, and there's a lot of information in there for something that's relatively simple, but it kind of helps you understand how the blockchain works, how the unspent transaction output mechanism works as opposed to a standard accounting ledger. There's a difference between the two, and UTXO is what Bitcoin and Cardano use to track the information. So basically you can follow the Satoshi, is what some people say. You can take any quantity of money in Cardano and follow it back to the Genesis block using the different addresses. I don't know how to do it. It's pretty difficult. You can do it on those websites, or maybe you can talk to a software engineer. But the key in this video was learning how Daedalus works and how UTXO works. Primarily, how does UTXO work? What does it look like in Daedalus? And how does it appear moving from wallet to wallet? What I'm going to do is get a little bit more practice, and also using it with Yoroi, talk to some of the engineers, and hopefully I'll make a more advanced video showing more UTXO transactions to get you more familiarity, because it took me a while to get to this point to where I understood it well enough to be able to make a video and at least look at it and work through it and demonstrate to you guys how it works. Otherwise, you're going to spend a lot of money in transaction fees playing with it, trying to figure out how it works. I still think it's a good idea to try practicing. If you're new to it and it doesn't make sense, is make some extra wallets in Daedalus, maybe make a Yoroi wallet in Chrome, and send some transactions back and forth. At this period in time, it's January 2019, and ADA is still relatively inexpensive, so it doesn't cost a whole lot to learn how to use it. But I can imagine 4 or 5 years from now, if the transaction fees are still 0.2, you'd be saying, well, that's going to cost me a little bit of money, but the transaction fees might come down. The key is, though, that you understand a little better of how UTXO works. I hope you got something out of this video. If you did, feel free to click subscribe, hit the like button, and if you want notifications of more videos coming out, hit the bell, and that will give you notifications each time I post a video to YouTube. Y'all have a great day. Bye-bye.